Hello. Yeah, let's start now. At first, I would like to introduce myself, and Henrik will introduce him also. My name is Jianfeng Ding. I'm from Intel Beijing team. We are working on the cloud software. Okay.
And my name is Henrik Blixt. I'm the product manager for Bio, proudly showing off my Swedish ancestry.
Okay. Yeah, I would like to talk about the background of our collaboration work. In Intel have a very big, large scale cluster in Santa Clara. It's about more than 500 machines. It's supposed to be used by the community or the partners to do some validation works. We know VMware has a very solid software in cloud. So the VIO product is based on open source OpenStack. And we in the testing work we have two objectives. One objective is we want to do some performance and scalability testings for the VIO in large-scale clusters. And another objective is we want to try the large-scale deployment issues. Yeah. Through the testings, we have found a lot of inputs, and we have a lot of findings from the testing. Henrik will talk about that in the following pages. And actually, we have two cycle testings in the last 2 years. At 2016, we have a relative smaller cluster testing with 132 nodes. And last year, we have a testing in 500 nodes clusters. Yeah, that's very helpful to us. Next page. Yeah, this is basic information of the software and the hardware configuration for the testings. For the software, we can see we are using VMware, the cloud software suite. It's about for example, vCenter and vSphere Hypervisor in 6.5 version. And for the networking part is using the NSX-T 2.8G version. And for the VIO OpenStack product, we are using the 4.0 version. For the server physical server configurations, we can see the server machine, we are using 2 sockets, Intel E5 V3 CPU. For every CPU, we have 12 cores. And the memory is 256 gigabit. And for the SSD configuration, we are using the regular SATA SSD and one high-speed NFV PCIe interface SSD. And the network, we have 2 NICs with Intel X710 10 gigabyte NICs. Okay. For the testing secondary settings, for this token, we will more focus on the second cycle testing for the 500 nodes cluster testing settings. We have 2 scenarios. One is the multiple vCenter, and another one the large vCenters. Yeah, for different testing purpose for the. And the VM, we are using 2 VM flavors. One is M1 media, and another one is M1 small for different testing also. Right? For the virtual machine scale settings, we are using 20 tenants and 2 users per tenant. And for the benchmarking tools, we are using OpenStack Rally project. And for the test is the workloading design for the testing, we are using SSH connective and also WordPress applications for the workloading settings. Okay. We will also share some OpenStack parameter settings in the slides also. Yeah. This is the network topology. For the testing environment setup, actually, I think this is a very common network topology design with 35 racks full of servers. And I think the network setting is very common. No, nothing special. Yeah, I would not waste more time for this part. Yeah, next is Henrik. Yeah. Thank you.
So just quickly, so VMware integrated OpenStack. We fully compliant OpenStack distribution. So these are basically the services we support. And underneath here in the bottom, we see what parts of the VMware SDDC stack we run on. So one of the goals of this test was to see, were there any bottlenecks in the OpenStack components? Was there any bottlenecks in the VMware components? And just take the learnings we did from the small test and then apply that to a larger 500 node test. So basically, VIO, pull OpenStack code from upstream like everyone else, and then we run that in VMs. So the biggest difference, and we see here on the deployment architecture, is that we, being VMware, of course, run everything virtualized. So all the control plane services, our management service that's the VIO manager there over on the left side, as well as the Nova Compute are all virtualized and running under ESX. The other big difference that we do in VIO that other OpenStack distributions don't do is that we use the clustering construct in ESX. So instead of having a one-to-one mapping with the Nova Compute to host, we actually have a Nova Compute mapping to a cluster of hosts. It can be any number of, or up to 64, 124, whichever version of vSphere you use, number of hosts. So we wanted to see as well, like, what tuning parameters can we do there to maximize the performance of the number of hosts we have in these clusters. Other than that, it's fairly standard OpenStack networking diagram of how deployment would look like. And then we used Rally to do the test as mentioned. So I'm just going to flip through these real quick. If you want to study these in more detail, download the video, watch the video on YouTube, and hit pause. So basically, we did the test in 4 different availability zones. So we had them grouped in 4 different Nova zones. So you can see those 3750 instances in each. So you can see how the Nova and Cinder duration, the time for that grew as we scale up the number of instances. Basically, we did a Nova boot, Nova attach volume, and the Cinder create volume. And you can see here how the times increased as we went through the test. We also did a fairly lightweight test with heat stacks, basically getting the classic WordPress application up and running, like everyone else does. So just see what the timing was for that as we're going through those stacks. So the key findings, last few minutes here, basically we ran this in the 500 node cluster we did. We didn't really see any bottlenecks on the OpenStack side, and we handled up to 15,000 VMs just fine, the 500 nodes. We didn't hit any bottlenecks on the VMware side either. So we know that we can scale to at least 500 and 15,000 VMs, but we don't know how much further. We just know that we can definitely go further than that. We also noticed was that better performance, our newer version of NSX T transformers performed better than the NSX-V we used in the previous lab with 132 node test here a couple of years ago. We did notice that as we used that cluster concept instead of a one-to-one mapping with Nova Compute, we do trade a little bit of performance in boot up time for a larger scale. So we might not be able to boot up as fast, but it looks like instead we'll be able to scale to much higher number of hosts. And of course, as we scaled up, we saw some degradation in time as the number of objects increased in the system. And we also wanted to play around. We played around a little bit with the size of those clusters. And it seems like a good size seems to be around 10, 12, 14-ish, depending on how much load you put. If you have more static workloads, you can go much higher. We have customers that run much more than those 12. If you're using OpenStack or VIO for more CI/CD workflows, you'd have a really high churn. You might have to tune that down a little bit. But more than happy to discuss that in more detail later. We also saw as with the 4.0 version that we tested this on, which we announced 5.0 here 2 days ago. So this was the previous version that we released last fall. What we did there, we also introduced, so vCenter is what basically manages the VMs, the VM creation for ESX and vSphere. So the feature we added there was the ability to have more than one vCenter. So in the previous scale test we did, we only had one vCenter managing those 132. So we wanted to see what happens when we add a larger number of vCenters. So in this test we did up to 4 vCenters, and we saw that the scale and the performance didn't increase by 4, but it's at least linear as we add those on there. So you can see our performance increased as we added more vCenters. So in the future here in the next releases, we'll scale up the number of vCenters that we can support, and we'll be able to go even higher in scale. So just want to acknowledge and thank Intel for lending us all this hardware and helping us with the hardware setup so we could do the tests. And also a big shout out to our team in China, our Beijing engineering team that did all of the testing for us. So thank you, Intel. Thank you, everyone, for stopping by and listening to us.